You have already seen the pictures. That thin, bright line of dust pointing the wrong way. The anti-tail that doesn't seem to care where the sun is. You have heard people mention the strange blue glow after perihelion, and maybe even the quiet radio signal that refuses to flicker. The news keeps saying it is safe, but the anomalies keep stacking. That is why you are here. You have spent months hearing about 3i Atlas from every angle you can find. Short clips, long streams, Reddit threads that go on for miles. Some people call it just another odd comet. Others swear this feels different, even if they cannot say exactly why. Tonight, you are not looking for another quick reassurance or another dramatic thumbnail. You want something rarer. A calm walk through the real debate behind December 19th, guided by someone who will not talk down to you or talk you into a panic. You saw the title and felt it land in the middle of everything you have been silently wondering. The debate on December 19th. Is it a real threat to Earth? You know the official answer to the simplest version of that question. You already know there is no impact coming, no last-minute turn toward our world, no hidden orbit that every observatory somehow agreed to lie about. If this were about a rock slamming into the planet, you would not be relaxing in your chair, letting this play in the background. This would be a very different kind of night. But something about 3i Atlas keeps tugging at you. It is not the idea of fire in the sky. It is the sense that this visitor is wrong in all the interesting ways. A tail pointing toward the sun when it should be blown away from it. A chemical fingerprint rich in prebiotic ingredients, pushed out into space in a pattern that refuses to match the textbook. A steady radio line where you are used to seeing noise. A smooth, gentle push that does not behave like random jets of vapor. If all of that is really nothing, you want to understand why so many smart people are still arguing about it. So let's be clear, right from the start. Tonight is not about fear. It is about precision. It is about taking that word threat and breaking it open into pieces you can actually think about. There is the physical threat, the one your survival instincts care about most, and that one can be set aside very early. There is no collision coming on December 19th. There is no plausible way for this object to suddenly curve into us. You deserve to hear that in plain language. But there are other kinds of threat, and that is where the debate lives. There is the threat to your sense of how comets are supposed to behave. The threat to old models that worked well until something interstellar wandered through and refused to play along. There is the threat to the idea that our solar system is a quiet, closed neighborhood. There is the threat to your sense of control, to the belief that the universe will always stay comfortably inside the lines you drew for it years ago. None of these will crack the crust of the earth, but they can shake the map in your head. Tonight, you are going to hear how different people handle that shaking. You will see why one group of astronomers looks at the same data and shrugs, calling 3i Atlas a bizarre but natural comet. You will see why another group looks at the chemistry and thinks about life, about seeds drifting between stars, about the possibility that what or who we are did not start here. And you will see why a smaller, more speculative camp looks at the thrust, the anti-tail, the blue glow, and the quiet radio line, and asks whether we are looking at a machine instead of a rock. You clicked because you want more than a yes or no. You want a map of the arguments. You want to know what will actually be watched on December 19th, what a normal night would look like in the data, and what would truly count as strange. You want to be able to look up at the sky that night, or scroll through the news the next morning, and feel like you are ahead of the story instead of chasing it. So, this is the promise of the time you are about to spend. You will not get jump cuts, sirens, or countdown clocks screaming at you. You will get a clear picture of where the orbit is, what the latest observations show, what the main camps in the debate are saying, and how all of that fits into the idea of a real threat. And then, when we are done, you will be able to let 3i Atlas drift back into the dark, knowing that whatever it turns out to be, you met it with understanding instead of fear. For now, all you have to do is let your body sink a little deeper into wherever you are sitting or lying. Let your shoulders drop and let your curiosity stay awake just a little longer. The universe is not knocking on your door tonight. It is simply passing by, and you have chosen to watch with open eyes. Before you go any deeper into debates or possibilities, you deserve to hear the clearest and most grounded truth of this entire story. 3i Atlas is not going to hit Earth. Not on December 19th. Not accidentally. Not through some last-minute gravitational surprise. Not through any hidden curve the model somehow missed. You can let that worry go completely. And to understand why, let's start with the thing most people skip over too quickly: the shape of its path. 3i Atlas is moving on a hyperbolic orbit. That means the eccentricity isn't just high, it's greater than 1. This is the mathematical signature of a visitor, not a resident. An interstellar object doesn't loop through the solar system the way comets born here do. It arrives from deep space. It bends slightly as the sun's gravity brushes against it, and then it leaves, following a line that stretches back toward the dark it came from. No loops, no returns, no second passes. It's a flyby tourist, not a returning visitor. And even at its closest approach, the distance is enormous. We are talking hundreds of millions of kilometers, more than the space between Earth and Venus, far beyond the range of any near-Earth object that would ever raise a red flag for planetary defense teams. If Earth were the size of a basketball sitting on a court, Atlas would pass farther away than the distance from that court to another city. That is how wide, how calm, and how uneventful this flyby truly is. But maybe you're wondering about something subtler. Could it change direction? Could a burst of gas, a shift in solar wind, or some overlooked force push it toward us? It's natural to ask, especially if you've been following the news closely, the way so many people have these past few months. But the answer, again, is deeply reassuring. There is no energy source available that could steer an object this massive into a new course. No venting of vapor could generate enough sustained thrust. No planet, moon, or gravitational interaction is positioned to tug it into an earthbound trajectory. Not even the sun can bend it so sharply. Momentum at interstellar speeds is not something that turns just because we fear it might. And if you've heard rumors or whispers online about hidden data, late-night corrections, or secret orbit updates, the kind of speculation that floats around social media Whenever a rare object shows up, here is something worth holding on to. NASA isn't the only group tracking this. 4 independent observatories using different detectors, different angles, and different methods have solved the orbit separately, and their solutions match almost perfectly. When different teams produce the same trajectory, using their own math and their own equipment, that is how you know the path is real. No one is covering anything up. There is simply nothing dramatic to cover. Now that the facts are on the table, you can feel your shoulders unlock a little. You can feel that quiet shift inside when your brain finally believes what the numbers have been saying all along. You are not watching a disaster approach. You are not counting down to some hidden danger. You are simply observing a rare interstellar traveler passing through, giving astronomers a brief window to collect data before it slips back into the dark. And yet, if the physical danger is non-existent, why is everyone still watching? Why are professional astronomers debating its behavior? Why are the communities you follow, on Reddit, on streaming channels, in the comments of every astronomy video uploaded this month, still so fascinated? That is where the real story begins. Not in the orbit, but in the behavior. Not in the risk, but in the questions. You can fully relax now. The sky above you is as steady as it has always been. No threat is approaching Earth. No impact scenario is hiding behind December 19th. But the reason you're still here, the reason millions of people are following this object, is because its behavior refuses to fit into a simple box. And once the fear is gone, the curiosity can finally breathe. So with the physical worry out of the way, you and I can now move toward what you actually came for. The wild chain of discoveries, anomalies, surprises, and debates that brought us to this moment. Now that your mind is clear and every idea of danger is out of the way, let's fast forward through the story that brought us here. Not the long, heavy version you've heard a dozen times, but a crisp, clean recap. The kind that gives you all the context you need without making you feel like you're sitting through old news. Think of this as the movie trailer version of the last 6 months. The runway leading straight into the newest updates we're about to explore. It all began back in June. Astronomers scanning sky survey data expected more of the usual: faint rocks, icy bodies, drifting debris. But then came a point of light, moving just a little too sharply, a little too fast, on a path that didn't bend the way local objects bend. Within days, the orbital solution came back, hyperbolic. And that one word changed everything. This was not another comet looping its million-year route around the sun. This was something from the outside. The third confirmed interstellar object ever detected, following Oumuamua in 2017 and Borisov in 2019. It was faint, it was distant, and it didn't look like either of its predecessors. Not like a comet, not quite like an asteroid, just different. By August and September, the first strange behaviors began to stack up. Observers noticed a lopsided glow, a bright streak of dust that wasn't centered where it should be. Then came the jets, but not the messy, chaotic jets you expect from an icy traveler approaching sunlight. These were narrow, directional, almost intentional in the way they pointed. As more spectra came in, the chemistry raised eyebrows too. Methanol and hydrogen cyanide in ratios that didn't match typical solar system comets. Nothing alarming, but unusual. And then, almost quietly, the color shifted. At first a rusty red, the way many comets look when sunlight hits dusty organic material. But then it slid toward green, a clean, sharp green that deepened week after week. A visual signal that made even the most casual observers wonder what this visitor was made of. October added the moment that turned the astronomy world's head. The first clear images showed an anti-tail, a long, bright streak of particles pointing toward the sun instead of away from it. A structure created when large dust grains fall behind the comet along its orbital path. But this one looked sharper than expected, and brighter, and longer. That shouldn't happen, muttered more than one astronomer on social media. And while the explanation wasn't supernatural, the geometry was striking enough that the images spread fast. It became one of the first viral snapshots of 3I Atlas, the moment many people started following the story closely. November arrived with an avalanche of new data. Hubble delivered its first high-resolution images, revealing a structure that was anything but ordinary. The coma showed layers, filaments, intricate shapes that didn't match standard models. One member of the Hubble team put it simply, the structure is highly unusual. Nearly at the same time, the MeerKAT radio array in South Africa picked up a faint, persistent radio line associated with the object. Not strong, not artificial, but clean enough to get everyone's attention. Brightness increased more rapidly than expected, with surges that came in short pulses rather than the smooth rise most comets show. And as the object shed more material, heavier particles began to appear in the dust stream, larger and denser than typical ejecta. Not dangerous, but surprising. Then came perihelion, the turning point. As it swung closest to the sun, 3I Atlas changed again. The green intensified into a richer, deeper color. Jets tightened into sharper beams. Outgassing patterns shifted from wide fans into narrow streams, almost like the object was rotating with a rhythm we hadn't seen earlier. Chemical ratios became clearer. Particle sizes increased again. The entire behavior looked less like what astronomers predicted and more like a new category nobody had quite pinned down yet. And for many people watching, perihelion became the moment when fascination turned into debate. So let's step back and take this all together. The discovery, the color shifts, the anti-tail, the radio line, the jets, the chemical signature, the unusual structure, the surprising brightness surges. All of that happened before the most recent observations, before the newest measurements, before the latest discussions that have filled comments, forums, and late-night live streams across the astronomy world. Everything you've just heard was the warm-up act. And the most exciting part? This recap is not even the beginning of the recent developments. The real surprises came after perihelion, in the weeks leading right up to now. Hubble's highly unusual remarks, ALMA's chemists saying, "We don't see this chemical ratio very often," and a dozen observatories quietly agreeing that this object refuses to behave like anything routine. Which brings us to the present moment. December approaching fast, the world watching, the debates intensifying. You now have the full map of how we got here, without a single wasted detail. Your mind is ready for the good part, the reason you clicked, the updates that people are still arguing about right now. And now, here are the updates from the last few weeks, the part everyone is talking about. Now, we step into the part you've been waiting for. The reason you clicked. The reason the astronomy community has been buzzing louder with every passing day as December 19th approaches. Everything from this point forward is new. The late November and early December data, the fresh observations, the refined measurements, the surprises nobody predicted months ago when this interstellar visitor first slid into our sky. If the first 3 segments built the foundation, this is where the real structure begins. This is where you finally get the updates that make the debate so alive, so split, and so compelling. So let's go through them one by one, clearly, calmly, and in a language that's easy to follow even while you're winding down for the night. The newest Hubble images taken on November 30th arrived like a spark tossed into dry grass. Not dramatic to the untrained eye, but unmistakable to anyone who's been following this story. The anti-tail, that long, thin streak pointing toward the sun instead of away from it, is still there, still sharp, still bright. And this time, Hubble measured it at nearly 60,000 kilometers in length. That's larger than many planetary ring structures. And more importantly, it refuses to curve the way sunlight and the solar wind should bend material streaming from a comet. Normally, dust blown off an active nucleus shows graceful arcs, gentle sweeps, soft curves. What Hubble sees instead looks almost like a jet. Narrow, straight, intensely collimated, like a beam more than a plume. Astronomers were quick to clarify that nothing about this suggests technology, but they were also quick to say this: it isn't matching our models, and that alone keeps the debate very much alive. The ALMA observatory added a different kind of puzzle. Using high-resolution spectroscopy just before and after perihelion, ALMA measured the relative amounts of methanol and hydrogen cyanide, 2 molecules that tell scientists how ices are being heated, processed, and released. But instead of behaving like a standard solar system comet, the ratio shifted in a way that doesn't match simple warming. Methanol increased on the sun-facing side, while HCN decreased, something ALMA's team described as chemically asymmetric outgassing. In clean, simple terms, parts of the object are reacting to sunlight differently than others. Not chaotic, not dramatic, just unusual. And when interstellar objects behave unusually, people notice. One ALMA astronomer put it plainly: we don't see this chemical ratio very often. The MeerKAT radio array brought its own twist. When astronomers look at comets in radio wavelengths, they expect noise, flickering, pulsing, random variations caused by spinning surfaces and uneven jets. What MeerKAT sees instead is a carrier wave that refuses to vary. It doesn't rise and fall with rotation. It doesn't shift with solar wind changes. It just sits there, steady and calm, like a tone played on a single note. This is not a sign of communication. It's not a message, but it is an oddity. Stable carriers are unusual in comets, one researcher said on record. And that's enough to feed a dozen different interpretations online. From the purely natural to the deeply speculative. Another update arrived from dust analysis instruments. Heavy particles, not grains, not flakes, but macro particles, larger than what comets typically shed, and dense enough that solar radiation doesn't push them away easily. These chunks appear to linger near the object longer than expected, creating patterns that don't match typical tail profiles. Some astronomers argue this is simply large clumping, something that can happen when icy crusts fracture unevenly. Others say the persistence and density of these particles make 3I Atlas look more like a rubble object than a snowball. None of these interpretations carry danger, but all of them add to the list of things that don't quite fit. Then came the blue. As the object rounded the sun and began moving outward, infrared readings from JWST detected rising temperatures along the sunlit side. That part is normal enough. But the visible light color shifted again, this time toward a soft, unmistakable blue. Green before perihelion, blue after. The kind of blue glow typically associated with ionized gases, but in a distribution that's wider and more diffuse than standard ion tails. One ESA scientist summarized it with a kind of stunned honesty. The blue excess is something we didn't see coming. And for many people watching from home, the color shift alone became a sign that 3I Atlas is not done surprising us yet. Put these updates together, and you get the shape of what's happening in the astronomy world right now. A few scientists remain firmly in the weird comet camp, the group that believes every anomaly can eventually be folded into natural explanations once more data arrives. But more and more voices are saying something different. Not that this object is artificial, not that it's extraordinary in a way that defies nature, but simply that the stack of anomalies is getting tall. Anti-tail persistence, chemical asymmetry, stable radio emission, heavy macro particles, blue glow after perihelion. You don't need them to add up to something dramatic. They're already interesting on their own. And that's the point. None of these updates suggest danger. None of them point to threat. But every one of them deepens the mystery. Every one of them adds one more layer to the debate that is now happening in research labs, online forums, and quiet conversations between astronomers who have spent their entire careers studying icy bodies and still find themselves surprised. As Avi Loeb said when asked about the accumulating oddities, if it walks like a non-comet and talks like a non-comet, he didn't finish the sentence. He didn't need to. The implication hangs in the air, light as dust and sharp as curiosity. So these are the latest updates, the newest pieces of the puzzle, the details that make this upcoming December 19th not a moment of fear, but a moment of attention. And all of these updates bring us to the heart of tonight's topic, the anomalies that fuel the debate. Before we walk into the debate, before we hear the arguments, the theories, the interpretations, the late-night opinions of astronomers and enthusiasts, we need something simple, clean, and powerful. A scorecard, a map, a way for your mind to sort through everything 3I Atlas has been doing that comets should not be doing. So let's lay it all out. If 3I Atlas were a student in a normal Comet 101 class, how badly would it fail the exam? Let's go anomaly by anomaly. For each one, we'll compare the rulebook, the standard things comets always do, with what this interstellar object has done instead. And by the end of this segment, you'll have a crystal clear picture of why the debate around Atlas exists and why it's louder now than ever. Let's start with the first and most visually striking behavior, the anti-tail. In the comet rulebook, tails point away from the sun, always. Solar radiation pressure and the solar wind push dust outward, creating beautiful arcs that drift behind an icy nucleus as it approaches the sun. That's the rule. But Atlas doesn't seem to care about the rule. Its anti-tail is narrow, long, and persistent, pointing directly toward the sun. Not just one night, not just one observatory. Multiple detections, multiple angles. The structure is too straight, too sharp, and too stable to match the graceful curves we expect. And so, in the scorecard, tail behavior. The second anomaly is the blue glow after perihelion. Normally, comets brighten as they near the sun, shed ices and gas, then fade and cool as they move away. Their colors soften from bright to gray, sometimes to red, but rarely anything more dramatic. Atlas, on the other hand, has gone through 3 phases: deep red, then green before perihelion, and now, as it moves farther from the sun, an intense electric blue. Blue is not impossible, but this timing is. Blue usually indicates ionized gases, high-energy processes, or interactions that require significantly more stimulation than simple warming. But Atlas is cooling. It should be calming down. Instead, it's shining in high-energy colors. And so the scorecard marks another red cross. Cooling pattern. The third anomaly lies in its chemistry. Many comets contain hydrogen cyanide and methanol. But the ratio between these molecules is usually modest, a few units, maybe a few dozen. Atlas shows a methanol to HCN ratio around 124, a value almost unheard of aside from one extremely unusual comet observed years ago. Even more strange, ALMA data shows methanol extending far down the tail, while HCN remains clustered near the nucleus. That asymmetry implies a chemical process that doesn't match simple solar heating. So once again, chemical fingerprint. Anomaly. Number 4. The heavy particles. Comets shed dust. Fine. Light grains that the solar wind pushes away easily. But Atlas is shedding something else. Pebbles. Large enough not to be blown off track. Dense enough to linger. A few astronomers believe these could be fragments of a crust breaking apart. Others suggest the density implies a much stronger internal structure than expected. Whatever the explanation, this is not how dust dynamics normally work, and so, dust dynamics. Then there's the 5th anomaly, the smooth, non-gravitational acceleration. In comets, outgassing produces thrust. Jets fire off randomly, creating uneven pushes that cause tumbling or chaotic rotation. But Atlas shows a smooth, consistent acceleration. Subtle, but stable. Its orientation seems controlled, not flailing. The acceleration doesn't wobble. It doesn't pulse with the inconsistent rhythm of melting ice. It's too even, too steady, too clean. And so the scorecard gets another mark. Outgassing thrust behavior. The 6th anomaly is the radio emission. Comets can produce natural masers, amplified radio signals, but they're variable. They flicker as the nucleus spins, as jets open and close, as sunlight changes intensity. Atlas, however, produces a radio signal at 1665 and 1667 MHz that simply does not vary. MeerKAT expected noise. It got a tone. Stable, persistent, unmoved, and in the scorecard, radio variability. The 7th and final major anomaly is the jet structure. Comets often have jets, but they're fuzzy, chaotic, constantly shifting. Atlas again breaks the pattern. Its jets show sharp boundaries, clear edges, and a persistence that holds across processing styles and wavelengths. The images don't look like wisps. They look like lines. And so yet, another X lands on the page. Jet morphology. So let's pull it all together. A full scoreboard of how ATLAS performs when judged against the rulebook of normal comets. Tail behavior, cooling pattern, chemical fingerprint, dust dynamics, outgassing thrust, radio variability, jet morphology. That's a lot of red marks for a normal comet. Enough to make even the most conservative astronomers raise an eyebrow. Enough to make the more adventurous ones lean forward in their seats. Enough to make the online debate explode into dozens of theories, some grounded, some speculative, some simply curious. And here is where the real twist lands. If this were just one weird behavior, we could ignore it. But this isn't one anomaly. It's a pattern, a stack, a collection of behaviors that, together, paint a picture nobody expected when 3I Atlas was first discovered. As Avi Loeb once said, anomalies are nature's way of telling us our textbooks are incomplete. Another astronomer put it more casually. This object refuses to behave. And now that you know the full scorecard, now that you see the red marks lined up clear as day, you're ready for the real show. The debates, the camps, the competing explanations for what ATLAS might be, and why it's breaking so many rules. So with this scorecard in mind, let's step into the arena and hear what each camp has to say. Now that the scorecard is in your hands, now that you've seen how many rules 3I Atlas has bent, broken, or simply ignored, it's time to step into the arena. Because facts alone don't shape the story. Interpretations do. And tonight, the first voice we're going to listen to is the one that keeps the conversation grounded. The voice that hates hype. The voice that has seen decades of comet scares come and go. This is Camp A. The skeptics. The classic planetary scientists. The dynamicists who breathe orbital mechanics as naturally as air. The astronomers who roll their eyes every time someone online shouts aliens over a fuzzy image. These are the folks who have seen a lot of comets, weird comets, noisy comets, broken comets, spinning comets, comets that brightened when they shouldn't and faded when they shouldn't. And to them, the story of 3I Atlas sounds familiar in a way the rest of us might not recognize. Their first argument comes quickly and confidently. The universe has weird outliers all the time. Comet 67P. Remember the rubber duck comet? That one had cliffs, boulders, vents, and a shape no one saw coming. C 2016 R2. That comet had chemistry so bizarre, with CO dominating everything, that scientists joked it was the comet that forgot to be a comet. And of course, Oumuamua, the enigmatic first interstellar visitor, which twisted and tumbled and accelerated oddly enough to trigger years of debates. That still settled into a mostly natural explanation. Camp A says, weird tail shapes, weird chemistry, weird rotations. We've seen all of it before. None of it turned out to be artificial. Their message is simple. Nature is creative. We shouldn't jump to aliens. Their second argument leans on something every scientist understands deeply. Data is incomplete and noisy. Different observatories use different detectors. Different nights produce different atmospheric conditions. Background subtraction can amplify structures. Image processing can sharpen or distort shapes. Stack enough noisy data sets, you'll find anomalies in anything, even objects that are perfectly normal. To Camp A, the anti-tail might simply be a perspective effect. The radio signal might be a stable masser we just haven't seen from an interstellar object before. The chemical ratios might come from only sampling a tiny part of the coma. The message beneath their calm tone is this: don't build castles out of noisy pixels. Their third argument focuses on motion. You've heard that Atlas seems to have smooth, non-gravitational acceleration, almost like a gentle thrust. But Camp A doesn't see anything shocking there. They point out that comets have jets, and jets cause thrust. Some comets, when averaged over time, have stable, non-gravitational terms. Smooth, they say, is relative. The solar system has plenty of icy bodies whose spin and outgassing eventually fall into rhythm. Chaotic behavior is common, but order isn't impossible. Their fourth argument targets chemistry. The ALMA methanol to HCN ratio is extreme. No one denies that. But Camp A reminds everyone that our comet sample size is tiny, a fraction of what exists. Billions of comets drift through the universe. We've only studied a handful with high-resolution spectroscopy. So why assume the rare equals artificial? To Camp A, the chemical cocktail of Atlas may simply be a flavor we haven't tasted yet. Their fifth argument cuts to the heart of the UFO-style speculation. There is no direct technosignature, no resolved structure in the nucleus, no geometric shape, no engineered fragments, no repeating radio pattern, no encoded signal, just gas, just dust, just light, just the universe doing something strange, which it does all the time. And so their conclusion is confident, steady, and free of drama. 3I Atlas is a very weird comet, maybe a fragment of something older, maybe from a system with different chemistry, but it is not a threat, not physically, not intellectually. The only real threat is our tendency to overreact to things we don't understand yet. For Camp A, safety is not a question. Stability is not a question. Natural explanations still outweigh exotic ones by a wide margin. Their tone isn't dismissive. It's grounding. It pulls your feet back to the floor. It reminds you not to let imagination run too far ahead of evidence. As Michael Brown once put it, if you stare at the sky long enough, you'll always find something that doesn't fit your first model. And another skeptical astronomer adds the line you've probably heard many times before. Extraordinary claims demand extraordinary evidence, and we're not there yet. But here's the quiet twist. Even Camp A, the most skeptical group in this whole story, agrees on one thing. 3I Atlas is worth watching closely. Not because it's dangerous, but because it is teaching us something new, whatever that something turns out to be. Camp A keeps us grounded. But the next group, Camp B, sees something else in the anomalies. Not danger, not technology, but possibility. Because to them, what 3I Atlas is made of matters just as much as how it behaves. But for many astronomers, weird but natural doesn't feel like the whole story, especially when you look at what 3I Atlas is made of. Now let's step into a softer corner of the debate, a gentler one, a camp made not of skeptics or engineers, but of scientists who spend their lives thinking about life, how it begins, how it spreads, how fragile and how persistent it can be. This is Camp B, the Panspermia enthusiasts, the astrobiologists, the organic chemists, the dreamers in lab coats who genuinely believe the universe itself might be a gardener, scattering seeds across the dark. They're not talking about spaceships or aliens with intent. or anything frightening. Their view is romantic science, the idea that life, or at least its ingredients, flow between stars the way pollen floats on wind. If Camp A grounds you in rational caution, Camp B lifts your mind upward into cosmic possibility. Their first argument is chemical, and it begins with a simple truth. The chemistry of 3I Atlas screams prebiotic. Methanol, CH3OH, is one of the simplest alcohols and one of the best building blocks for complex organics. Hydrogen cyanide, HCN, is a backbone molecule for amino acids and nucleobases, the heart of DNA and RNA. But it isn't just the presence of these molecules that excites Camp B. It's the ratio. Atlas shows a methanol to HCN ratio so high it sits far outside the norm for solar system comets. It's the kind of ratio you'd expect from ices that have been processed in unusual environments. Dense, carbon-rich, nitrogen-rich regions where organic chemistry can run wild. To Camp B, this looks less like a frozen snowball and more like a flying chemical laboratory carrying the ingredients of life. A cosmic pouch of biological potential drifting from one star system to another. Their second argument focuses on the heavy particles, the pebbles, those strange, oversized fragments Atlas is shedding. Unlike dust grains, they don't get blown away by the solar wind. They linger. They survive. They travel slow enough and long enough that they could, in theory, fall into the gravitational wells of young planetary systems. And if those pebbles carry organics, or something even more complex, then they can act as seeds. Durable, radiation-resistant seeds traveling for millions or billions of years. As one Panspermia researcher joked, if you were a cosmic gardener, you'd want durable seeds. The third argument Camp B makes is about origin. 3I Atlas is interstellar. It is not a leftover from our solar system. It comes from somewhere else, carrying the chemical fingerprints of a different nursery. And because it carries chemistry that doesn't match our local recipes, Camp B sees this as a remarkable opportunity. Life could follow different rulebooks elsewhere. Different blends, different pathways, different sparks that lead to self-replicating molecules. Panspermia doesn't require intent. It doesn't require intelligence. It doesn't require engineers or technology. It only requires physics. The slow, patient physics of drifting ice and rock and organics traveling across stars. The fourth argument expands on this idea. Within Camp B are two temperaments. There are the romantics, the friendly gardener voices, who imagine Atlas as a vessel unknowingly sowing life across the galaxy. Not like a ship, but like a dandelion puff, scattering possibilities wherever it goes. And there are the cooler, more reserved thinkers, the ones who say, it's just physics, but physics that accidentally spreads life. Both groups believe something beautiful. Life might not be local. Life might not be rare. Life might be a cosmic process that didn't begin here and won't end here. That perspective is powerful and comforting. It makes the universe feel connected, not empty. When Camp B talks about threat, they don't mean danger. Not at all. Their version of threat is philosophical. The first threat is to our sense of uniqueness. If life's ingredients arrive from across the stars, then Earth is not the isolated miracle we once imagined. We might be part of a much older, broader chain of chemistry stretching back before our sun even formed. The second threat is a question many astrobiologists whisper. If life is easy to spread, why haven't we seen anyone yet? If the universe is constantly seeding potential, why does it still feel so quiet? But even that is more reflective than frightening. Camp B doesn't bring anxiety. They bring awe. They invite you to picture a universe where life is not rare, but inevitable, not confined to Earth, but flourishing wherever conditions allow. Their conclusion is warm and poetic, the kind that gives late-night astronomy videos their magic. 3i Atlas might be a natural Panspermia vessel, a drifting carrier of organics from another star, a comet rich with the soup that life needs to begin. And the only threat it poses is to the idea that Earth is the center of biological history. Because once you open the door to Panspermia, you also open the door to an older, wider story, one where our origins stretch far beyond the solar system. Fred Hoyle said it decades ago, life is a cosmic phenomenon. And Francis Crick, one of the fathers of genetics, once admitted, the origin of life appears at the moment to be almost a miracle. Tonight, Camp B invites you to consider that maybe the miracle didn't happen here. Maybe it drifted here. And if this is the friendly gardener camp, you might be wondering what the next group sees. Because not everyone believes Atlas is simply scattering chemistry into the dark. But not everyone sees 3i Atlas as a drifting seed carrier. Some see something sharper, more deliberate. Now we turn to the boldest corner of the arena. Not the grounded skeptics of Camp A, not the romantic chemists and cosmic gardeners of Camp B. This is Camp C, the group that sees 3i Atlas and asks the question many people whisper but few dare to say out loud. What if this is what an artificial object looks like from far away? They are not conspiracy theorists. They are not alarmists. They are thinkers, Technosignature researchers, engineers, physicists, and people who take the Fermi paradox seriously. People who look into the quiet dark of the universe and wonder whether something, somewhere, might be looking back. They are open-minded, not reckless, speculative, not hysterical. And tonight, we'll walk through their reasoning slowly, safely, just enough to feel the spark of possibility without falling into fear. Camp C starts with the anti-tale. To them, this isn't simply dust aligned in an odd way. It's a plume, a vector, a controlled thrust against the direction of the solar wind. Natural tails point away from the sun. But Atlas's anti-tail doesn't care about sunlight or radiation pressure. It stays tight, straight, and persistent, like something pushing toward the sun rather than being pushed away from it. And here is where the engineers lean in. If you wanted to use the sun to perform an Oberth maneuver, a way to burn near a star to gain enormous speed, you'd fire your engines at exactly the moment Atlas did, near perihelion, right where the anomalies spike. To Camp C, the narrator explains, that's not proof, but it is interesting. Their second argument revolves around the blue glow. After perihelion, as sunlight decreases and the object should be cooling, Atlas shifts into a deep electric blue. Blue in physics often means energy, flames, lightning, particle interactions, Cherenkov radiation. Camp C asks, what if the object isn't cooling? What if an internal energy source is still idling as it leaves the sun? They don't claim it is an engine, but they point out that natural comet exhaust rarely turns more energetic as the object moves farther away from heat. The blue glow, to them, signals a controlled system, not a chaotic one. The third argument, one of their favorites, is the stable radio signal. Natural masers flicker, they pulse, they change with rotation, outgassing, sunlight, and chaos. Atlas doesn't. Its signal holds steady, flat, unmoving, like a carrier wave. Camp C knows this is not a Hello Earth message, but to engineers, it resembles something familiar. A beacon, a telemetry channel, a low-power relay. Most machines, they say, don't shout in poetry, they hum in carrier waves. Their fourth argument uses physics of motion. Natural outgassing is messy. It tumbles objects. It spins them in unpredictable ways. But Atlas, its non-gravitational acceleration is smooth, steady, directional. Its orientation stays stable instead of behaving like a rock, being pushed unevenly by jets. Camp C imagines something else. Attitude control. Gas used not for randomness, but for steering. Jets behaving like stabilizers. Anti-tail thrust acting like a directional correction. Again, not proof, but a pattern. Their fifth argument is one of the most provocative. The heavy particles, the pebbles, that Atlas sheds like breadcrumbs. To Camp C, these aren't just debris. They could be markers, samples, long-lived capsules meant to drift for centuries after the main object passes by. A way to map, to test, to tag systems for future revisits. If this thing is a scout, they whisper, it might be leaving breadcrumbs behind. And here is where the concept of threat shifts. To Camp C, the threat is not an impact, not a collision, not destruction. The threat, if you can call it that, is conceptual. We are no longer off the map. We may not be alone in the cosmic silence. Someone, or something, might now know we exist. But Camp C is careful. They stress that being observed is not the same as being attacked. If Atlas were hostile, it would not drift silently by at millions of kilometers, leaving no sign of intent. If anything, this hypothetical scout behaves like a patient one, deliberate, quiet, gathering data, not provoking a response. This is where the narrator steps in gently, grounding the mood. Is this scenario likely? Maybe not. Is it impossible? Also no. Speculation? Yes. Science fiction flavored by science? Yes. But still tethered to reality. Still responsible. Camp C's role in the debate isn't to assert truth. It's to widen imagination. To remind us that the universe is old, vast, and full of unanswered questions. That technosignatures won't look like Hollywood ships. They'll look like physics we can't explain yet. Avi Loeb once said, "When you hear hoofbeats, you think of horses, not zebras. But once in a century, a zebra does walk by." And Jill Tarter, a pioneer of technosignature studies, frames it beautifully. We are doing archaeology on the future. To Camp C, 3i Atlas might be one of those future artifacts. A sign not of danger, but of company. And whether their ideas prove right or wrong, they add something invaluable to the story. Possibility. A sense that the cosmos may be more alive than it looks. A sense that our quiet sky might not be empty, just patient. 3 camps. 3 radically different interpretations of the same object. And all of them watching Atlas with the same intensity as December 19th approaches. 3 camps. Three very different stories about the same object. But what about the people watching all of this unfold? While scientists debate their models, calculate their ratios, argue over chemical fingerprints, and write papers late into the night, something else has been happening across the world. Something quieter, softer, and maybe even more important. People everywhere are talking. Not just academics or professionals, but ordinary skywatchers, fans of space channels, curious night owls, radio hobbyists, Reddit explorers, and the thousands of people who have spent the last few weeks checking updates every evening before bed. As we move into this next part of our journey, imagine stepping into a warm, softly lit room filled with voices. Not loud, not frantic, just people, your people, talking about the same object you've been following. Different ages, different backgrounds, different cities, but all looking up at the same sky and wondering what 3i Atlas might mean. Because no matter which camp you personally lean toward, A, B, or C, this moment belongs to all of us. We're living through a rare cosmic event, one happening in real time, and the world is responding with curiosity, connection, and the kind of excitement you don't get every decade. The first group of voices you hear in that imaginary room are the curiosity voices, the fans of astronomy who dive into Reddit threads, Discord chats, and small YouTube channels. In RR Astronomy and R Space, the posts climb to the top of the feed. This is the most interesting interstellar object since Oumuamua. Why is the tail pointing the wrong way? Anybody have new spectra? They're not afraid. They're energized. These are people who look at the heavy particles and the blue glow and the anti-tail and think, this is weird. And weird is fun. Small astronomy YouTubers, the ones filming from backyards and computer labs, join the chorus. I've never seen a chemical ratio like this. I had to redo my script because ALMA released a new update. It feels like a comet that forgot the rules. Their tone is light. Their faces glow with excitement. These voices aren't anxious. They're thrilled to be witnessing something new, but scattered throughout the room are softer, more hesitant voices. The voices of gentle anxiety, often from people who sound a lot like you. People who trust the data, trust NASA, but who can't quite let go of the little what if that lingers in the quiet moments. Comments from American viewers, over 40, show up again and again. I know NASA says it won't hit us, but I still can't stop checking updates. Why does it keep changing color? Is that normal? I'm not scared, just curious. Maybe a little too curious. Their tone is not fearful, just human. A reminder that even in a calm universe, our minds can get loud. And that's okay. Curiosity and uncertainty often travel together. Then there are the voices of pure excitement, the once-in-a-lifetime crowd. The older sky watchers who remember seeing Halley's Comet in 1986. We might never see something like this again in our lifetime. This reminds me of the excitement back then, but bigger. And younger fans who weren't alive for any major comet event. This is my first interstellar visitor. Feels surreal. It's wild to think our generation gets one of these. The tone in this corner is celebratory, almost festive. For them, 3i Atlas is not a puzzle or a threat. It's a story, a moment they'll tell their kids or grandkids about. A moment when a visitor from another system passed through ours, and they were there to see it. Over by another table are the people adding humor, the memes, the cosmic jokes that make the discussions feel warm and human. These comments drift across Discord channels and YouTube chats like friendly sparks. Atlas can't hurt Earth, but it's definitely hurting my sleep schedule. If aliens show up, I hope they fix my student loans. Is it weird that I'm rooting for the comet like it's a sports team? Humor is the heartbeat of community. And for viewers over 40, especially those watching at night, this humor lands gently, like a nod from someone who understands exactly how invested you are. Then there are the voices of the people in the middle, the balanced thinkers, the I don't know yet crowd. Perhaps the most relatable group of all. They say things like, I don't think it's artificial, but I also don't think we fully understand it. Maybe it's natural, maybe not. But it's definitely not boring. I'm just here for the mystery. These voices aren't choosing sides. They're choosing wonder. They're choosing to stay open, to let the data speak as it comes. And when you step back and listen to all these voices together, the curious, the anxious, the excited, the humorous, the undecided, a pattern emerges. A global feeling. Regardless of differences in tone or opinion, everyone shares three emotions. Curiosity. Nobody is bored. This object has captured imaginations from Seattle to Seoul. Uncertainty, not fear. Just a sense that we're watching something unfold in real time, and we don't have all the answers yet. Excitement. A sense of witnessing something rare, something historic, something that reminds us how big and surprising the universe still is. Carl Sagan once said, "We are a way for the cosmos to know itself." In moments like this, when millions of people are watching the same point of light for different reasons, that quote feels true in a way that warms the room. And then there's the comment that appears over and over in different forms, different voices, different languages. This thing feels like the universe tapping on our window. And maybe that's why you're here. Not because you fear Three-Eye Atlas, but because it tapped and you answered, just like everyone else in this room. Now that we've heard from the world, let's turn our attention to the day the world is waiting for. The moment circled on calendars. The moment fueling live streams, debates, and quiet conversations across continents. So let's talk about the day everyone is waiting for. December 19th. December 19 won't be dangerous, but it will be interesting. That one sentence is the anchor of this entire chapter. No fear, no countdown to doom. Just the promise of a day when the world's telescopes will quietly turn toward the same object, the same moment, for the same reason. Something unusual is passing by, and its closest approach is a window into its true nature. You are not watching for impact. You are watching for information, the kind that can only be revealed when an object is at its brightest, most active, and most exposed to the sun's forces. And on December 19th, astronomers across the globe will focus on 7 specific parameters, 7 dials, 7 clues, 7 questions that, if you understand them, will help you see more than the average person scrolling through headlines. Thing number 1. Brightness curve. The very first graph scientists will stare at on December 19th is the brightness curve. How the object's light output rises and falls over hours. They will watch for 3 things. Does it brighten faster than expected? Does it dim suddenly? Does it spike or drop within a single 24-hour window? If 3I Atlas is venting normally, the brightness will follow a predictable slope. If it has an internal energy source, or directional outgassing, or any unexpected behavior, that slope will wobble or jump. Brightness is not just light. It's a story about heat, gas, energy, and structure. It's the heartbeat. Thing number 2. Color spectrum. The second indicator is the color. Not just blue, red, or green, but the individual spectral lines that reveal molecules, ionized gases, temperatures, and plasma states. Astronomers will ask, does the blue phase deepen or fade? Do new emission lines appear? Are any wavelengths behaving strangely after perihelion? Color is physics. Color is chemistry. Color is motion. Color tells you why the object is glowing the way it is. If 3I Atlas emits an unexpected line, even one narrow spike, that becomes headline news in the astronomy world. Thing number 3. Tail orientation. The tail, or tails, of 3I Atlas are its most photogenic features, but they are also diagnostic tools. The question scientists will ask on December 19th is, does the anti-tail change direction? Does it react to solar wind at all? Does the vector shift by even a few degrees? If the anti-tail remains locked toward the sun while the object moves, that's notable. If it shifts in a way that aligns with solar wind models, that's equally meaningful. Tail behavior reveals force. Force reveals mechanism. Mechanism reveals origin. Thing number 4. Radio signal. MeerKAT in South Africa will capture radio windows around December 19th, listening for any changes in the stable narrowband emissions previously detected. Astronomers will pay attention to, does the frequency drift? Does the intensity rise or fall? Does any modulation appear, even faint, even momentary? A stable carrier is unusual. A shift is even more unusual. Silence is also data. If 3I Atlas is venting naturally, the signal may flutter. If something about the object is structured, internal, or engineered, the stability or instability of that tone becomes a clue. Thing number 5. Heavy particle emission. One of the strangest behaviors of 3I Atlas has been the emission of heavy particles. Pebbles, macro dust, call them what you want, far larger than typical comet grains. On December 19th, astronomers will watch. Do we see another burst of heavy particles? Do they stream out in a direction that makes sense? Does the count increase or decrease? These particles don't blow away easily. They linger. They trace paths. Their movement can reveal whether outgassing is random, structured, or influenced by something internal. Thing number 6. Rotation and tumbling. If 3I Atlas begins to tumble, even slightly, the community will know within hours. Rotation is visible in brightness modulation, jet alignment, and tail behavior. What astronomers will watch is simple. Does anything indicate rotation? Does anything destabilize? Do jets reorient or flicker? A stable rotation can imply symmetry. Too much stability can imply control. Any change in rotation on December 19th will stand out like a siren. Thing number 7. Trajectory refinement. This is not about whether it will hit Earth. It won't. That part is over. Settled. Mathematically locked down. But astronomers will refine the exact acceleration pattern, post-perihelion energy behavior, whether the non-gravitational push stays smooth or shifts. These micro changes reveal a lot about what is driving the object. Solar heating, directional jets, Internal processes, something else. Trajectory is the fossil record of force. Every update after December 19th will tell us more about the engine behind the motion. What you will see before, during, and after December 19th. Think of the close approach as having 3 phases, like watching an eclipse, but stretched across days. Pre-approach, now through DEC 18. Gradual brightening, subtle color shifts, small refinements. Data trickles in. Peak, DEC 19. Maximum activity, best spectra, best radio window, clearest tail geometry. Every observatory that can point will point. Outbound, DEC 2023. Colors change again. Brightness stabilizes. Jets may evolve. Radio may quiet or intensify. The object begins telling the second half of its story. You will experience all 3 phases. You'll know precisely what to look for. You'll be watching like an astronomer, not just a bystander. And here's the quiet twist. Even if nothing dramatic happens, that still means something. Silence itself is data. Stability is a clue. Predictability teaches as much as surprise. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." And Avi Loeb reminds us, absence of evidence is not evidence of absence. December 19th isn't the day something happens to Earth. It's the day something happens in our understanding of 3i Atlas. And now, with that in mind, let's step into the deeper question behind tonight's title. But threat, real threat, is not just about physics. It's about us. You've spent the last hour walking through data, debates, anomalies, and possibilities. Now, let's slow the universe down. Let's breathe. Because when people ask whether 3i Atlas is a real threat, very rarely are they actually talking about physics. They're talking about something far more human. So tonight, instead of asking, "Is the object dangerous?" we ask the deeper question. What does the word threat even mean when we talk about the cosmos? And maybe even more importantly, what scares us more, the object or the uncertainty? That's where this chapter begins. You hear the question in the quiet voice of someone older, wiser, someone who has lived long enough to know that not all fear comes from outside. Some fears are echoes of our own minds, our own stories, our own expectations about how the universe should behave. And 3i Atlas, well, it is not following our script. Threat type 1, the ego. Threat, a part of you, a very ancient part, still sees Earth as the center of the story. The warm hearth, the safe cave, the place where everything important happens. For thousands of years, humans looked up and believed the universe revolved around us. We were the main character. Everything else was supporting cast. Then a visitor arrives. Quiet, cold, travel-worn from another star, carrying chemistry and mysteries we didn't ask for. Not dangerous, not hostile, simply independent of us. And in that moment, the ego trembles. Because the universe is suddenly larger than our narrative, larger than our worldview, larger than the comfort of thinking we understand our place. But here is the truth whispered gently to you. Being small is not an insult. It is freedom. A small planet in a big cosmos means there is more to learn, more to explore, more to hope for than we once imagined. That is not a threat. That is expansion. Threat, type 2. The control threat. Humans fear what we do not control, not because it's dangerous, but because we cannot negotiate with it. You can't bargain with gravity. You can't reason with radiation. You can't ask a comet to slow down or speed up or behave the way you prefer. And here lies a subtle truth. The cosmos doesn't ask for our permission to be strange. It never has. Every anomaly in 3i Atlas, every color shift, every tail, every grain of dust is a reminder that the universe is not built for our comfort. It is built for its own beauty. So when people feel uneasy, it's not because 3i Atlas is doing something to us. It's because it refuses to fit inside the neat boxes we've built for celestial objects. It is the unknown reminding us that we are not in control. But control is not the same as safety. You can be safe without being in control. And that is the lesson hidden in this moment. Threat type 3, the narrative threat. We all live inside stories. Stories we inherited. Stories we tell ourselves. Stories like, comets behave one way. Life starts one way. Interstellar visitors look one way. The universe is predictable. Then along comes an object that breaks half the rules in the textbook. Not violently, just casually. Like a traveler stepping into a room and politely rearranging the furniture. And suddenly, the old stories wobble. But here's the soft correction. 3i Atlas is not threatening the story. It is simply turning the page. Every era of astronomy has had this moment. Galileo with Jupiter's moons. Herschel with Uranus. Hubble with the expanding universe. JWST with galaxies that were too old, too early. Each threat to the narrative was actually an upgrade. A patch. A better version of the truth. 3i Atlas might be exactly that. A nudge that says, there is more. Threat. Type 4. The silence threat. You might think humans fear danger, but we fear silence more. We fear not knowing. We fear the blank spaces in maps, the quiet after a strange sound, the unanswered question. And right now, 3i Atlas is a quiet object, a mute traveler, a puzzle without a key. That silence bothers us. It wakes up something ancient, something primal, the instinct to fill the quiet with stories, hopeful ones, fearful ones, scientific ones, and speculative ones. But here is the truth scientists live by. Science grows in silence. Data takes time. Meaning takes patience. Silence is not a threat. It is a space where understanding can breathe. This is the moment where the tone shifts into the heart of Sleepy Universe, where the narrator gently places a hand on your shoulder and says, the only real danger is that we get so anxious, so lost in what ifs, that we forget to enjoy the mystery while it's here. Think about it. How many times in life did you rush through something amazing because you were too busy worrying about what might go wrong? 3i Atlas is not a threat. It is an invitation to feel awe again, to remember what it's like to be curious without fear, to rediscover the joy of witnessing something that doesn't fit neatly into the categories we already know. This moment, this month, this close approach is a chance to step outside the noise and look up with the kind of wonder you had as a child. Not naive, not uninformed, just open. The universe is not a quiz with right or wrong answers. It is not a test you pass or fail. It is not a threat waiting to happen. It is a story. Long, deep, filled with chapters written in starlight, dust, gas, radiation, gravity, and mysteries we have not yet learned to read. Every anomaly is not a warning. It is a new paragraph, a reminder that the cosmos still has surprises left. And in a life where so many things repeat, work, news, routines, responsibilities, surprise is a gift. So maybe 3i Atlas isn't here to test us or judge us, or watch us, or frighten us. Maybe it's here to remind us that we are still capable of wonder. You, sitting here tonight, listening to this story, waiting for December 19th, you are part of a very old tradition. Humans gathering around mysteries, not to fear them, but to feel alive in their presence. Carl Sagan once said, "We live in a universe of possibilities." And Alan Watts added, "The mystery of life is not a problem to be solved, but a reality to be experienced." Tonight, between those two thoughts, is where peace lives. And now, let's close our night the way all cosmic stories should end. 3i Atlas drifts farther now, its electric blue fading into the dark. Not suddenly, not dramatically, just slowly, like a lantern carried down a long hallway until its glow becomes a memory more than a light. You picture it moving through the cold beyond Mars, the last hints of its ion blue shimmer dissolving into the black. For a moment, you hold that image. Wide space, no sound, no urgency, nothing chasing or being chased. Just a quiet traveler, moving along a path older than our sun. And as it drifts outward, you begin to feel the weight of the night settle around you, gentle and warm. We have come a long way together in this story, from that first discovery back in June, to the strange jets, the shifting colors, the signals, the debates, to the excitement that rippled across astronomy forums, YouTube communities, Reddit threads, and living rooms just like yours. You've watched scientists argue their models. You've heard dreamers speak about Panspermia. You've listened to engineers and Technosignature hunters propose bolder ideas. And you've heard ordinary skywatchers say, "This is something I'll remember for the rest of my life." All those voices, all those perspectives, they were part of the journey, part of the shared moment humanity had with a visitor from another star. But the visitor is leaving now, and nothing frightening has happened. No impact, no danger, no sudden shift in its path. Just a cosmic passing, watched closely, talked about widely, wondered about deeply. Now, as it recedes into the dark, you can let your shoulders relax. You can let your breath fall into a softer rhythm. You can allow your mind to unclench from the intensity of the debates. Because tonight, the truth is simple. We observed, we wondered, we learned, and we are safe. The universe did not send us a threat. It sent us a reminder that mystery still exists, a reminder that wonder still shows up unannounced, a reminder that no matter how routine life feels down here, out there, the cosmos is still writing chapters we didn't expect. What if, just imagine, the universe was not warning us, but inviting us to pay attention, not to fear, not to panic, but to remember what it feels like to look up. There's a certain beauty in moments like this, moments where you and millions of other people on Earth quietly share a sense of anticipation, even if the object is far beyond the reach of your eyes. Moments where the unknown feels less like a threat and more like a doorway cracked open, letting a little light through. You don't need all the answers tonight. You don't need to know what every anomaly meant, or which camp of the debate was closest to the truth. You don't need certainty to rest. You only need space, the same kind of space the cosmos has in abundance. So let this be the moment where your breathing slows. Let this be the moment you release everything you tried to hold too tightly. Every question, every theory, every what if. Let them drift outward, the way 3i Atlas is drifting now, getting smaller, quieter, lighter, until they no longer require your attention. You can rest now, the cosmos seems to whisper. The world is still here, the sky is calm, and nothing harmful is coming. Feel how comforting that is. Feel how rare it is to let yourself believe it. You are allowed to, because it's true. Far beyond the planets, past the quiet orbit of Jupiter, beyond the thin sunlight, past the cold dust, 3I Atlas becomes a tiny spark, a grain of light against an ocean of black, and then, not even a spark, just another silent traveler, returning to whatever dark its long journey began in. You imagine that stillness. You imagine that cold, peaceful emptiness wrapping around the object. No noise, no drama, no deadline, just motion and silence. And that silence begins to echo inside you too. A soft quiet that settles gently over your thoughts, like snow falling in slow motion. This is the part of the night where the universe feels close, where its vastness doesn't make you feel small, but held, where the distance between stars feels like room to breathe. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." It is a beautiful truth, and a gentle one, a reminder that mystery is not the enemy of peace. It is the companion of curiosity. And Brian Cox reminds us, the universe is almost entirely composed of nothing, and yet it is beautiful. In that nothingness, there is calm. In that quiet, there is room for rest. So tonight, as 3I Atlas continues its slow departure, as it becomes one more story in the long library of cosmic visitors, you can let yourself drift too. Not away, but inward, to that quiet place where the mind loosens and the heart softens. You are safe. You are here. And the universe, for all its strangeness, for all its mysteries, is quiet tonight. Let that be enough. Let it carry you gently toward sleep, the way a calm tide carries a boat. Everything you needed to know, you know now. Everything that mattered has already been said. Everything else can wait until morning. Good night. Sleep well. The universe is quiet tonight.